Structural isomers are compounds that have the same chemical formula, but they have a different arrangement of atoms. They're bonded in a different order. So if we start with, say, an alkane chemical formula that has 4 carbons, remember, just as a brief reminder, alkanes have a general formula of CnH2n plus 2. So we have 4 carbons, we have 10 hydrogens, C4H10. How many different ways can we arrange these atoms? I prefer to draw these in the skeletal form because it's just faster for me. Remember that carbon is going to want to make 4 bonds. Hydrogen is going to make 1 bond. And as we move forward with other examples, oxygen will make 2 bonds in order to fill its octet. And that's just a brief reminder from Chem 1. And then nitrogen usually wants to make 3 bonds. It's capable of making 4, but it usually wants to make 3. So we're going to start here with this information. And here we have what is called butane. And specifically, we would call this N-butane. It means it's all in a line. Now, if I take one of these methyl groups here and hang it off the middle, then we have what's called isobutane. We can also call that 2-methylpropane. If you aren't sure if you have structural isomers, name the compound. Each structural isomer is going to be a different compound. So let's try another one. The more carbon atoms you have, the more structural isomers are possible. So here we have a 5-carbon alkane. So I'm going to start with drawing pentane, and this is just called pentane. You could call it N-pentane if you want to be specific and particular, but it is pentane. If I take one of those methyl groups and I put it on my second carbon here, then I have what is called 2-methylbutane. Now this can commonly be called isopentane. That's the common name. The IUPAC name uses the numbers. Well, what if I put that methyl group here? Well, it's still 2-methylbutane, so I do not have an additional structural isomer by putting the compound here. It's the same compound. Well, what if I put this methyl group, then what if I migrate it on this side? Then I have this structure, and I end up forming, this is a quaternary carbon. So this is called 2,2-dimethylpropane. See, we name the longest carbon chain. We do not have any functional groups, so 1, 2, 3. We have 2 substituents. They're both on carbon 2. So 2,2-dimethylpropane. Now, as a common name, this is called neopentane. And I'm not going to expect you to know neopentane. But you see, we have 3 structural isomers when we have 5 carbons, but we only had 2 structural isomers when we had 4 carbons. Well, what if we move out of the alkanes? What if we do something a little more challenging? So if we have the chemical formula C3H6O, how many different ways can you arrange those atoms? If you have your model kit, this might be easier because you pull out those atoms and you see how many different ways you can arrange them. So I like to start with my skeletal structure. So here I have a CH3. I'm just going to fill these in for this one. A CH2. I need to get that O on. So here I have an oxygen. This is currently a CH2, and that uses 7 hydrogens. So what does that mean? Well, that means I must have a double bond. So here I have used my 6 hydrogens, I have used my oxygen, and my 3 carbon atoms. So the first structure I drew, this is called propanal. You see the aldehyde functional group here at the end and the 3 carbons. So what else can I draw with these 3 carbons? Well, I could make an ether like this. This is a CH2. This is a CH3. This is a CH3 that uses too many hydrogen atoms. So I'm going to make my double bond. And once you have located that you have one double bond, you need to have a double bond in all of your structures. So here we have, this is called methoxyethene. You could also call this, the common name would be methyl vinyl ether. This is a vinyl group when it bonds. Now we could also move this double bond. Analogous to an aldehyde is a ketone. So if we make this ketone, this also uses 3 carbons, 6 hydrogens, 1 oxygen. This is called 2-propanone. Propanone. And the common name is acetone. Now, when we have this double bond, whenever you have a double bond, see if you can make a ring structure. So if I make a cyclopropane and put an OH, an alcohol group on it, then I have what is called cyclopropanol. So you see all of these compounds have this same chemical formula, but I am arranging the atoms in a different bonding order. Just to try to get through these a little bit faster. We have this compound, and I can move the OH to any of these carbons. And all 3 of these are different compounds. And finally, the tricky one that students will often overlook is putting the oxygen in a ring. Now, I wouldn't expect you to be able to name this compound. It's actually called trimethylene oxide, but you will not be expected to name this compound. Let's try one more. Let's make the structural isomers of a compound that has a chemical formula C3H8O. So I'm going to start by doing my skeletal formula. This is a CH3, this is a CH2, and just as it is, this is a CH3. So that's 3, 6, 7, 8. That uses my 8 hydrogens, but I have this oxygen that I must get in there. So I'm going to make an alcohol group as well. That uses all 8 of my hydrogens, all 3 of my carbons, and my oxygen. So this would be 1-propanol. I can also move that alcohol group up here, and we would call this isopropanol if we were naming it with the common name. 2-propanol would be the IUPAC name. If I put the alcohol group on this carbon, that is still 1-propanol. So that is not a new structural formula. So I would erase that. And because we do not have a double bond, those are the only structural isomers with this chemical formula.